We have an economy where the aggregate consumption function is given as C being equal to 140 plus 0.75 of YD. The 140 is our autonomous consumption, the amount of consumption that people go through, regardless of whether they have income or not. The 0.75 is our marginal propensity to consume, or MPC. The YD is our disposable income. So if people have $1 of extra disposable income, then they will spend the MPC of it, which is 0.75. The disposable income is basically our net income. We have our gross income, but we also have to pay taxes, and we might receive transfers if we have a government. In this scenario, we are paying taxes of 120, but we're receiving 0 transfers. So our disposable income, YD, is actually equal to our gross income, Y, minus 120. We also have government going through their government spending. They also receive taxes. Both are 120. And we have 0 transfers and also 0 net exports. And if you recall, net exports was equal to exports minus imports. Since we have our government spending and taxes being both equal to 120 and transfers are 0, what we can tell from this is that if we look at our budget balance, which is taxes, the income of the government, minus whatever they spend through government spending and transfers, it's exactly at 0. So the government is not running a budget surplus nor a budget deficit, which is also called a balanced budget. First, we need to find the planned aggregate expenditure function of this economy. Now recall that planned aggregate expenditures is just a planned part of the economy, which consists of consumption, planned investment, government spending, and net exports. Our consumption is given by the aggregate consumption function of 140 plus 0.75 of your disposable income, and recall that we already found our disposable income to be Y minus 120, that's our net income, plus planned investment of 250, government spending of 120, and net exports of 0. This gives us 510 plus 0.75 of our disposable income of Y minus 120, or if we solve this out even further, it gives us 420 plus 0.75y. So our planned aggregate expenditure function can be written as 420 plus 0.75y. Or if we wanted to keep the disposable income as is, then we can also write our planned aggregate expenditure function as 510 plus 0.75 of your disposable income, which is y minus 120. What's the equilibrium output of this economy? We know that in equilibrium, our Y equals our planned aggregate expenditures. In other words, our production, Y, is all being consumed through planned aggregate expenditures, whether that's coming from households, firms, government, or the foreign. In other words, your unplanned inventory investment, which is the difference between what you have produced, the Y, versus what you have actually demanded, which is your planned aggregate expenditures, is 0. You have demanded and consumed everything that you have produced in the economy. So in other words, using the information we found on the planned aggregate expenditures in part A, we know that Y needs to equal our planned aggregate expenditures of 420 plus 0.75Y. We'll solve it for y by subtracting 0.75y from each side and then dividing both sides by 0.25, which gives us an equilibrium output of 1680. We'll denote this as y star. Next, we'll find the spending multiplier. The equation for the spending multiplier is 1 over 1 minus MPC. Now, we know our MPC from our aggregate consumption function. Because we know that aggregate consumption is the sum of autonomous consumption plus MPC over disposable income, we can find out that our MPC is equal to 0.75. You plug it into the equation and we get a spending multiplier of 4. In other words, if we have an increase of our initial autonomous spending of $1, it'll lead to our output rising by $4. Next, we have the tax multiplier. We know that the equation is negative of MPC over 1 minus MPC. And since we already know the MPC, we can just plug that number in and we get -3 for our tax multiplier. Now suppose the government decreases government spending by 30. So our government spending was originally at 120, but because we're decreasing it by 30, now the government spending is at 90. Taxes are still at 120. What we know from this is that if we look at the difference between taxes and any type of spending through government spending and transfers, then it's actually no longer 0, but it's at 30, which is positive. So now, after this reduction in government spending, the government is running a budget surplus. Now let's find the new equilibrium output using the new planned aggregate expenditure function. We know that our planned aggregate expenditures is the sum of consumption, planned investment, government spending, and net exports. Our consumption function is still the same at 140 plus 0.75 of disposable income. Your disposable income is still y minus 120 because nothing has changed on taxes or transfers. Your planned investment is still 250. What has changed is your government spending. It's now lower at 90, and the rest, your net exports, is still 0. So your planned aggregate expenditures now, after the change, is 480 plus 0.75 of your disposable income of y minus 120. Or if we further solve it out, then we get 390 plus 0.75y as our new planned aggregate expenditure function. The equilibrium condition is still the same. We know that in equilibrium, still our output needs to equal our planned aggregate expenditures, except now we have a slightly different expenditure function. So our y now has to equal 390 plus 0.75y. We'll still solve it for y by subtracting 0.75y from each side and then dividing both sides by 0.25, which gives us 1560 for our new equilibrium output that we'll denote with double stars. The next part is asking you to do the same thing, finding the new equilibrium output after the decrease in government spending by 30, but by using the spending multiplier in this case. We know that the total change in output is going to come from the initial change in your autonomous aggregate spending, which is coming from the change in government spending in this case, and that's going to be multiplied by the spending multiplier of 1 over 1 minus MPC. The change in our government spending is a fall by 30, so the change in government spending, delta G, is -30. We'll multiply that by the spending multiplier of 1 over 1 minus 0.75, which is 4, which gives us the total change of output of -120. So the total change in our output is a fall in output by 120. Our original equilibrium output, y star, was at 1680. Our new equilibrium output will be the old equilibrium output plus any changes. We start from 1680. We know that the total change in output is going to be a fall by 120, which gives us the new equilibrium output, y double star, of 1560. And you see that we do get the same end result regardless of which method we choose, because it's just two different ways of seeing the same event, which is a fall in output triggered by this change in government spending. Now, if we were to depict this on a Keynesian cross, we'll start out by drawing the axes with the planned aggregate expenditures on the y-axis and output on the x-axis. We have the 45-degree line, which depicts all the possible points of equilibrium where y equals your planned aggregate expenditures. And we know that our original planned aggregate expenditures was 420 plus 0.75y. So your y-intercept is at 420. And then as your income rises, your planned aggregate expenditures also rise at the speed of 0.75. That's your slope of your planned aggregate expenditures. And then we saw our government spending falling by 30. And so we see our planned aggregate expenditures falling by 30 as well. So our y-intercept of the new planned expenditures is lower at 390, but then afterwards it's the same. As your output rises, your consumption rises, which means your planned expenditures also rise at the same speed of 0.75. So we see a parallel shift of the aggregate planned expenditures downward. So if we compare the two equilibrium points, right, the equilibrium is where the planned aggregate expenditure curve meets the 45-degree line, then we see that the original equilibrium, we found that it was at 1680 by solving for the equation y being equal to our planned aggregate expenditures. And graphically, we can also see that the point where the green planned aggregate expenditures curve meets the 45-degree line is on the left-hand side of the original equilibrium, and we know that it was at 1560, which is indeed lower than our original equilibrium. Now, when we were using the spending multiplier, what we were looking at was the initial change in our planned aggregate expenditures was negative 30 because of the fall in government spending. As a result, how much does our output fall in total? It's the initial change of negative 30 times your spending multiplier, which is negative 120. And here you can see that, yes, the new equilibrium is lower than the original equilibrium by 120. You can see that the fall in the total output is greater than the initial fall in government spending. And this is what we call the multiplier effect. Next, we have a different kind of fiscal policy happening. Your government spending will not change at 120 while your taxes rise from 120 to 150. So you'll still see the same budget surplus of 30 as a result, except that in this case, instead of reducing government spending, we're increasing our tax income. Then let's try to find the new equilibrium output. First, we'll do so by finding the new planned aggregate expenditures function. Again, we'll do the same thing. We know that our planned aggregate expenditures is the sum of consumption, planned investment, government spending, and net exports. Our consumption function itself is the same, with 140 plus 0.75 of our disposable income, except our disposable income is now lower at y minus 150. The rest is the same. Our planned investment is still 250, government spending is 120, net exports is 0. This gives us 510 plus 0.75 of our disposable income at y minus 150. Or if we solve it further, it gives us 397.5 plus 0.75 of y. We still have the same equilibrium condition. We know that in equilibrium, our production has to equal our demand, which means that our output y needs to equal our planned aggregate expenditures, except that we have a different planned expenditures function of 397.5 plus 0.75y. Again, we'll solve for y by subtracting 0.75y from each side and then dividing both sides by 0.25, which gives us 1590 as our new equilibrium output after this change in taxes. We know that we can also use the multiplier to find the new equilibrium output. Except that in this case, because we're seeing a change in taxes, we're going to use the tax multiplier instead of the spending multiplier. Again, the logic is pretty much the same. The total change in output is going to be equal to the initial change, which is coming from taxes, times the tax multiplier, which represents the multiplier effect. We know that the change in taxes is 30 because we saw a rise in taxes by 30. We know that our tax multiplier is negative 3, which gives us the total change in output as negative 90. So we see a fall in output by 90. To find a new equilibrium output, we know that we start from an old equilibrium output and we see any changes. So we started from 1680 and we know that our output fell by 90, which gives us 1590 as our new equilibrium output, which is exactly same as what we found out earlier using the first method. Again, we see that the initial change is actually smaller than the final change. This is referring to the multiplier effect, where the total change is larger than the initial change. Let's draw this out on the Keynesian cross. Again, starting with the axes of planned aggregate expenditures on the y-axis and output of y on the x-axis. We also have the 45-degree line, which represents all the possible points of equilibrium. Our original planned aggregate expenditures started at the y-intercept of 420 with the slope of MPC, which is 0.75, where the planned aggregate expenditures curve meets the 45-degree line is your equilibrium. We've already found out that it's 1680. Now, what happened after the rise in taxes? Our planned aggregate expenditures fell as a result because higher taxes mean people have less money to spend, but by how much? In the case of taxes, just because taxes rose by 30 doesn't mean that you'll be reducing your consumption by 30. Why? Because your MPC, or marginal propensity to consume, is between 0 and 1. In this case, it's at 0.75. So you are only consuming 75% of your disposable income, which means if your disposable income falls by 30, you're not decreasing consumption by 30 because you would have initially consumed only 75% of that 30 to begin with. Instead, you're going to see a little bit of a fall in your savings and also a little bit of a fall in your consumption. By how much? We can find that out by multiplying the MPC to the amount of change in your disposable income. And so we see a fall in the autonomous spending by 22.5, which leads us to have a new planned aggregate expenditure curve starting at 397.5 as the y-intercept. And after that, it's the same. We still have the same MPC of 0.75. And so we see a parallel shift of the planned aggregate expenditures downward. And graphically speaking, we can already see that our new equilibrium output is going to be lower. And we already found that the new equilibrium output is at 1590. So, in terms of the multiplier, if we see a rise in taxes by 30, then that means our disposable income falls by 30, out of which we've been only consuming 75% of. So our initial change in autonomous aggregate spending as a result of this rise in taxes by 30 is 0.75, the MPC, times negative 30. This initial change in autonomous aggregate spending also go through a spending multiplier, because if you spend 22.5 less, then someone's not getting that income of 22.5, so they're also going to reduce their spending. Our initial change in autonomous aggregate spending is MPC times negative of the change in taxes times the spending multiplier of 1 over 1 minus MPC. If we rearrange this, then we get 30 times negative 0.75 over 1 minus 0.75, which is basically the change in taxes times negative MPC over 1 minus MPC. This is how we get the tax multiplier equation that we saw earlier. And so, in sum, our output in total decreases by 90 as a result, which also gives us the same result of our new equilibrium output being at 1590. So in sum, tax multipliers are not very different from your spending multipliers. We just need to take into account the fact that taxes work in opposite directions. If there is a rise in taxes, then you're going to see a fall in your consumption and planned aggregate expenditures. And also, taxes tend to be a little more indirect because your taxes first affect your disposable income and consumption and not your planned aggregate expenditures directly. We can see this if we compare the results from the earlier parts when we had our government spending fall by 30 versus when taxes rose by 30. When government spending fell by 30, our new equilibrium output was at 1560, while if we have a rise in taxes, our new equilibrium output is slightly higher at 1590. That's because government spending has more of a direct impact on your planned aggregate expenditures. If government spending falls by 30, then your initial change in autonomous aggregate spending is negative 30. In other words, your planned aggregate expenditures falls by 30 immediately once the government decreases their government spending by 30. On the other hand, if the government raises taxes by 30, it initially affects the disposable income. People see relatively less amount in disposable income. They decrease their consumption, but only by the MPC of it, because people don't consume all of their disposable income. And so your initial change in autonomous aggregate spending, or the initial change that your planned aggregate expenditures sees after the rise in taxes, ends up being smaller compared to the change in government spending that we saw in the earlier parts. In other words, taxes are more of an indirect measure when it comes to fiscal policy. And so that's why you have a smaller change in output as a result when you're using taxes versus government spending. And that's why your new equilibrium output after the change in taxes ends up being higher than the new equilibrium output after the change in government spending. Finally, let's look at the case where the government tries to keep their budget balanced. In other words, they're going to decrease government spending by 30, which was what they were originally doing. But to keep the budget balanced, they're also going to reduce taxes. So your taxes minus government spending minus transfers, your budget balance is going to be still at 0. So you still have a balanced budget. Remember that because your amount of taxes are going to change, your disposable income is also going to change. Now it's going to be equal to y minus 90 instead of 120. Then what's the new equilibrium output? You can also use any of the two methods in this case, but I'm going to use the multipliers. So we know that the total change in output is the initial change in your autonomous aggregate spending times whatever multiplier that needs to be applied. In this case, we have two changes, one from government spending and another from taxes. We have our government spending initially falling by 30, and we know that's going to go through our spending multiplier of 1 over 1 minus MPC. At the same time, our taxes are also changing. It's falling by 30, and because the changes in taxes, it's going to go through the tax multiplier, which is negative MPC over 1 minus MPC, which we already found out to be negative 3. So the total change in your output ends up being minus 30. Or in this case, because we know that we're balancing the budget, we can use the balanced budget multiplier, where the original change is coming from either the government spending or taxes, but they're the same amount, which is at minus 30. Because we're trying to keep the budget balanced, the resulting multiplier is 1, so our total change in output is minus 30. Our new equilibrium output is your old equilibrium output plus any changes. Our original equilibrium output is 1680. We see a fall in output by 30, so we end up at this new equilibrium output of 1650. Why do we see different results? Well, that's because now to balance the budget, we're essentially using two different types of fiscal policy. We have a decrease in government spending, which is an example of contractionary fiscal policy. This is what we use to put brakes on our economy. At the same time, to keep the budget balanced, we're also decreasing taxes, which is an example of an expansionary fiscal policy. This is what you do if you want to accelerate your economy. because we're using two different fiscal policies that are going against each other, these multiplier effects end up canceling each other. And so if our original goal was to use a contractionary fiscal policy to step on the brakes, make sure our economy doesn't grow too quickly, then what we end up seeing is that the original contractionary fiscal policy, which is aimed at reducing planned out expenditures and reducing output, is not as effective. And we do see that our output still falls, but by less compared to when we're only using government spending or only using taxes.